Okay. Okay, that just got erased. But again, this should be -4/3, although I wrote that already. I think it just erased. Let me put it in again. Okay, right? Because again, you want to know when this equation is true, right? We're setting y to be 0, and we're determining the x-intercept, okay? Recording. I don't know if it was recording, it is. So this is the x-intercept. We set y to be 0, and we solve this for x, okay? I mean, you could go through the steps, but hopefully it's easy to see that you subtract 4 from each side, and then you divide by 3. So we get -4 over 3. Okay. Now we're going to move on to another special kind of graph called the parabola. The parabola is the graph of a quadratic equation. In other words, if you have something like this, y equals a polynomial of degree 2, right? This is a quadratic. The graph of this is called a parabola. That's what the graph is called. It's a parabola. Okay. Remember, it cannot be 0, but a, b, and c are fixed real numbers. I mean, what's nice about this, it's easy to get the y-intercept, as you can see. You basically just replace x by 0, and you get the constant term. For the x-intercepts, remember, you set y to be 0, and you have to solve the resulting equation. You know, you set the other variable to be 0. You set y equal to 0 here, and you have to determine x. So you can see we're back in section 1.2 when finding the wonderful x-intercepts. So you can factor, you can use the quadratic formula, you know, those will get you the x-intercepts. And let me just say this, though, actually. This will come up, I know this will come up later when we actually look at what are called quadratic functions. It turns out if a is positive, the graph's going to look something, it's going to open upward. So basically, the graph's going to look something like this, which we'll see shortly. Kind of looks like a cup, if that makes sense. That's if a is positive. So if a is positive, it turns out the graph has to open upward. Opens upward. And a cannot be 0, so it's either positive or negative. But if a, however, is negative, then it's got to open downward, like this. I'm drawing arrows. As you'll see, the graph actually does keep on going. You know, it's just something I wanted to point out. I mean, I would have pointed that out when we did what's called quadratic functions, but we haven't talked about that yet. So I just feel better pointing that out now. Now the parabola is going to look something like this no matter what a, b, and c are. I mean, if a is positive, it looks something like this. If a is negative, it looks something like this. Of course, the way the graph looks exactly will depend on what a, b, and c are. But it's going to have this general features. It's going to have this general shape, excuse me. As a specific example, let's take y equals x squared. You know, so again, how do we graph that? Well, we can choose x's, right? And really, you could choose any x you want, because no matter what you plug in for x here, you're going to get a number that makes sense. Okay? So for each x, we're calculating the corresponding y, and we get this. So when x is -2, the point becomes 4. So this would be our point A. When x is -1, let me just write that in. This is our point A. When x is -1, as you can see here, you replace x by -1. -1 squared is 1. We get point B, which is -1, 1. When x is 0, right, you get 0 squared, which is 0. So because of that, what we get is point C, which is actually the origin. So the graph passes through the origin. When x is 1, you get D, because 1 squared is 1, so you're at this point. Finally, this is point E, because when x is 2, 2 squared is 4. Okay. Notice also, you can really see from here that the x-intercept, right? Excuse me, the y-intercept, if you set x to be 0, you get 0 back. So 0 is the y-intercept. It's also the x-intercept. I mean, you can kind of see it from the graph here, because the only place that the graph touches the x-axis is at the origin, at 0. So 0 is the x-intercept. It's also the y-intercept. But that's what the parabola looks like. And any parabola, as I said, is going to look something like this. The graph actually does keep on going up, up, turns out. So it's going to look something like that. It might be flipped over, it might be shifted horizontally or vertically, but it's going to look something like that. All right. So now we have some examples we can do. So for instance, let's say we had 3x squared, 3x squared minus 3. Let's find the x-intercepts. Again, you set y to be 0, so the other variable, you would set that to be 0. And now we solve this equation. You know, we could factor, you can use the quadratic formula, whatever method I want you to use, I will tell you. But if I don't tell you, then you can use any method you want. I mean, for this one, I factored. For one thing, 3 is a common factor, right? So you can factor out 3. What's left is x squared minus 1. But x squared minus 1, that's actually, remember, it's a difference of 2 squares. X squared minus b squared. So we have x squared minus 1, but you could factor that to get this. And remember, when you have this kind of equation, you set each factor equal to 0 and solve. I mean, 3 can't be 0, so you can really ignore it. X minus 1 is 0, and x plus 1 is 0. From this equation, we get 1. From here, we get negative 1. Okay. So basically here, we're going through essentially 1.2. You know, this is something like we did in 1.2. You could also use the quadratic formula. The y-intercept, remember, that's pretty easy. You just set x to be 0, you get negative 3. So that's one example. So even though I didn't graph it, we can still obtain the x and the y-axis. I mean, I didn't graph it, you know, I mean, I could graph it, but I didn't. Okay. Here's another example. So for this one, okay, what we can do is we can determine, okay, the x and y axis. I mean, here it's graph, the x and y intercepts, excuse me. For this one, I used, okay, the, what do you call it, the quadratic formula, right? We have it equal to 0. For the x-intercepts, you set y to be 0. A is 1. B, which is 5. C is 4, right? It's always ax squared plus bx plus c. And so by the quadratic formula, we get x is negative 5. You know, negative b plus or minus the square root of b squared, 5 squared, minus 4 times 1 times 4, which is this. 25 minus 16, though. 25 minus 16, right? That's 9. And hopefully, I hope you remember that the square root of 9 is 3. But again, we have 2 solutions here, right? We have negative 5 plus 3, because this is plus or minus. So plus over 2. Negative 5 plus 3 over 2, which is negative 2 over 2, negative 1. The other solution is, instead of addition, you have minus over here. And that becomes this. Right? Negative 8 over 2 is negative 4. And yes, you can see that from the graph. What's nice about this, though, is we really don't need the graph to determine the x-intercepts. This one you actually could have factored. It's not hard to factor, actually. And for the y-intercept, you set x to be 0. And 4 is the only term with no x's, so that stays. Okay, so that's good.